Lesson 2, Smart Contracts. In this lesson, we are going to describe more in detail what are smart contracts. Smart contracts are self-executing scripts that encode the terms and conditions of an agreement directly into code. This contract automatically executes the code when specific conditions are met, eliminating the need for intermediaries and providing a trustless and decentralized way of executing agreements. Smart contracts are stored on a blockchain, making them immutable once deployed. Once a smart contract is written and deployed, its code cannot be altered or tampered with, ensuring the integrity of the agreed upon terms over time. The transparent nature of blockchain ensures that the code and execution of smart contracts are visible to all participants on the network. This transparency fosters trust among parties involved, as they can independently verify the terms and outcomes of the contract. Security is a paramount characteristic of smart contracts. The decentralized and cryptographic nature of blockchain technology makes it resistant to unauthorized access and tampering. Additionally, the immutability of smart contracts reduces the risk of fraud and manipulation. The main programming languages used to create smart contracts are Solidity, Viper, and Rust. Solidity is the most widely used programming language for developing smart contracts on the Ethereum blockchain. It is designed to be similar to JavaScript and is known for its simplicity and versatility in creating complex contract logic. Viper is an alternative programming language based on Python for smart contracts on Ethereum. It is intentionally designed to be more secure and simple than Solidity, with fewer features to minimize the potential for vulnerabilities. Viper is often considered for critical applications where security is paramount. Rust is gaining popularity as a programming language for smart contracts, particularly in blockchain platforms like Polkadot and Solana. Rust is known for its emphasis on memory safety and performance. Smart contracts play a pivotal role in the DeFi ecosystem. They automate financial processes such as lending, borrowing, and decentralized exchanges. Smart contracts enable the creation of decentralized applications, or DApps. These DApps provide open and inclusive access to financial services. Smart contracts facilitate the creation and management of tokens on blockchain platforms. These tokens can represent various assets, from cryptocurrencies to digital assets like virtual real estate or artwork. Token creation through smart contracts enables crowdfunding, tokenized assets, and the development of decentralized applications. Despite their advantages, smart contracts face challenges related to code vulnerabilities. Due to the immutability nature and transparent of blockchain, any vulnerability in the code can be exploited. Common challenges include reentrancy attacks, unchecked external calls, overflow or underflow integer operations, and unfortunately, many more. To address these challenges, rigorous testing, code audits, and adherence to best practice are essential in smart contract development to ensure their reliability and security. Let's break down the components that integrate the smart contracts. In the context of a smart contract, an address refers to a unique identifier that represents the location of the contract on the blockchain. Every smart contract deployed on the blockchain has its own address, which serves as a destination for interactions and transactions involving that contract. Addresses are typically represented as hexadecimal strings and are generated during the contract's deployment process. These addresses do not have a private key as the external owned accounts. The balance of a smart contract refers to the amount of cryptocurrency or tokens held by the contract at any given time. Just like individual accounts on a blockchain have balances that reflect the amount of cryptocurrencies they hold, smart contracts can also hold and manage digital assets with their balances. Smart contracts can also hold and manage digital assets within their balance. This balance can be manipulated through transactions and function calls that interact with the contract's code. The code of a smart contract consists of the programming instructions and logic that define its behavior and functionality. Smart contract code is typically written in high-level programming languages such as Solidity and is compiled into bytecode that can be executed by the Ethereum virtual machine. The code defines the rules and operations that govern how the smart contract operates, including how it handles incoming transactions, processes data, and interacts with external systems or other contracts. Once deployed on the blockchain, the code of a smart contract becomes immutable, meaning it cannot be modified or updated, and ensuring the integrity and reliability of its execution. The state of a smart contract refers to the current condition or data stored within the contract at any given moment. It includes all the variables, data structures, and storage elements defined by the contract's code that persist across multiple invocations and interactions. The state encapsulates the collective memory of the contract, capturing information such as user balances, transaction history, and any other relevant data managed by the contract. Changes to the state occur as a result of transactions and function calls that trigger updates to the contract's internal data, reflecting the dynamic nature of smart contracts as they interact with users and other components of the blockchain ecosystem. In summary, the components of a smart contract, which are balance, address, code, and state, collectively define its identity, behavior, and functionality within the blockchain network. The address serves as a unique identifier for the contract, while the balance represents the amount of cryptocurrency it holds. The code defines the contract's logic and operations, and the state captures its current data and condition. Together, these components enable smart contracts to execute programmable actions, manage digital assets, and facilitate automated interactions on the blockchain. Thank you.